Okay, today we're going to learn or review how to multiply rational numbers. Rational numbers are any number that you can express as a fraction. It might be written as a decimal, it might be written as a mixed number, it could be positive or it could be negative. So do a quick review of some things that will be significant in this today's lesson. And by the way, 4.5 is on, in the book, it's on multiplying and dividing, and we're going to split that into two separate lessons and cover dividing rational numbers in the next video. But remember that if you're multiplying and both numbers that you're multiplying are positive, like 4 times 3, the result is positive, so it would be positive 12. If they're both negative, then the result is still positive. And if one is negative and the other is positive, the result is a negative number. So keep that in mind when you're multiplying with a positive and a negative number. And you might have decimals involved in that, so a quick review of decimal multiplication. Let's say it's negative 3.2 times positive 4.1. This is close to the answer we were getting when we did negative 3 times 4, or it might have been negative 4 times 3, I don't remember. Same answer. It's going to be close to negative 12, but a little bit more, well actually a little bit less, larger absolute value. You can multiply this just like it's 32 times 41. It's going to be more than decimals while you do the multiplication. And then we put a 0 to hold that place value. 4 times 2 is 8, 4 times 3 is 12. Add them up. And we get 13.12. Well, we know the answer had to be close to an absolute value of 12, so the decimal has to go here. We know it's negative. And just to remember, the sort of the technical way that you determine decimal placement is to count the decimal places in the two factors. There's one here and one here that makes two decimal places, so you go over 2. So that is a really quick review of decimal multiplication. When you're multiplying two fractions, like a over b times c over d, the rule is to do a times c and b times d. So how does that play out with numbers? If we have 4/5 times 15 over 22, we would get 4 times 15 over 5 times 22, or 60 over 110, which is not going to be lowest terms. You can tell it's not lowest terms, because they obviously both can be divided by 10, they end in zeros. So it's pretty easy to see it's going to be 6/11. There's another way to do that, and this is pretty significant for your understanding and what's coming up with multiplying algebraic expressions in this lesson. And that is, you can take 4, and when you do the prime factorization, that's 2 times 2. 15 is 3 times 3. So another way to write this denominator is 4 times, sorry about that error, I hope you saw that, 3 times 5, 3 times 5, so this is a 4 times a 15. It's just written in a different way, and it's going to be a very convenient way to get to the idea of how you can cancel before you multiply. 5 is already a prime number, so just leave it as 5. And if we did a factor tree for 22, it would be 2 times 11. If you're able to do that mentally, that's fine. You shouldn't have to write a factor tree for these numbers that are pretty easy to see. It's one step to do. 2 times 11. And then you can rearrange the order here and make it 2 times... I'm going to go 2 times 2 times 3 times 5. I didn't change that name, but I'm going to make this one 2 times 5 times 11. I can take these and say 2 divided by 2 is 1. I could put the 5's together. I'm going to switch that order. 2 times 5 times 3 times 2. This is a 1. And this is a 6 and an 11, so it's 6 over 11. Or you can just start to work off a 5 and 5 is 1, 5 and another 5 is 1. What I'm doing there is using the division, equal fractions property, where I'm dividing both sides, both numerator and denominator by 5, which I'm allowed to do. Give an equal fraction, divide both numerator and denominator by 2. And again, we get 2 times 1 times 3 is 6. 1 times 1 times 11 is 11. It's 6 over 11 either way I do it. Oh, I did want to show really the simpler version of that. Would be just to look at the two numerators compared to the two denominators. And like, what goes into 5 that goes into 15? What is the greatest common factor? Which is 5. 5 goes into 5 one time, 5 goes into 15 3 times. What goes into, you could compare 3 and 22, but they have no common factors. But 4 and 22 have some common factors, a common factor, which is a 2. 2 goes into 4 2 times, and 2 goes into 22 11 times. And we get to the 6 11s a little bit easier this way. So it would be 2 times 3 is 6, 1 times 11 is 11. So let's take a look at mixed numbers. We think 4 1/2 times 4 2/3. And we could estimate this is about 4 or 5. This is closer to 5. Maybe if we're going to round off to estimate what the answer is, this is right in the middle between 4 and 5. And we see we're going to have to round this one up. It's kind of smart to round this one down and think of it as 4 times 5, which is 20. It just tells us our answer, if we do things right, should be close to 20. When you change, what we're going to do here is change the fraction, the mixed number to an improper fraction by saying, for every 4, for every 1, there are 2 halves. So there are 4 of them, so there will be 8 halves altogether, which is 2 times 4 is 8, and 1 more half gives us 9 halves. And 3 times 4, 12 thirds in the 4, and 2 more makes 14 thirds. If I wanted to make this kind of lengthy, I would say 9 is 3 times 3, 14 is 2 times 7. It may be lengthy, but it also explains why this works. And then 2 times 3, they're both prime numbers anyway. So then I can cancel an equal number of 2's here and here, and here and here. 3's get canceled, and I have 3 times 1 times 1 times 7, which is 21 on the top. And 1 times 1, 1. 21 divided by 1 is 21, which is pretty close to the estimate, so have some confidence that's the correct answer, 21, which 1 would be 21. So reduce before you multiply, which is the obvious way to do this problem. You see 2 even numbers here, so 2 can go into 2 one time, 2 goes into 14 7 times. 3 is a factor of 9, 3 goes into 3 one time, and 3 goes into 9 3 times. And then we get the 3 times 7 pretty directly. 21 over 1 is the answer. Now I'm going to go to probably the most difficult concept of this lesson of multiplying, because there's going to be some algebraic expressions in this. I want you to keep in mind that if you have something like 24a squared b to the third, that would be 24 times a times b times b times b. And 24, if you did the factor tree for 24, we can say it's 2 times 12. Now this is important in factor trees. This is a prime number, but you can't lose track of it. So you have to continue multiplying by that 2. 12 is 2 times 6. And at every step we should get 24. 2 times 12 is 24. 2 times 2 is 4, and 4 times 6 is 24. This is prime, we can just hold on to it. 2 is prime, hold on to it, and 6 is 2 times 3. And all the numbers here are prime. So this part of the expression is the same as 2 times 2 times 2 times 3. And this is a multiplied 2 times, and this is b multiplied 3 times. So if I wanted to expand 24a squared b to the third, it would look like this. 2 times 2 is 4, times 2 is 8, times 3 is 24, a squared b to the third. And you'll see in a second why this can be helpful. This is problem number 18 on page 89. I modified it a little bit, and I'll remodify it when I finish doing the work. a over 24b multiplied by 18b to the second over a to the second. And in the book, it's the opposite of a to the second power, and we'll deal with that after we take care of this. By the definition of multiplication, this would be a times 18b to the second power. And I'm just going to rearrange that to look like this. Because when we write the multiplication, we can multiply things that are different. So this is different. Things that are different are the same. Like terms in algebra are defined as the same variable to the same power. So these variables are different, a and b. So these terms by definition are not like terms. So we can multiply things that are not the same. We can't add or subtract them. This would be 24a squared b. That's the answer, but it's not lowest terms. And you're going to be asked to simplify. Just like you can simplify 18 over 24, you can do something with a over b, ab squared divided by a squared b. And here's what you can do with this. Rewrite 18 as in prime factor form. 2 times 9, 2 times 3 times 3. So there's our 18. I'm just going to tell you 24. I might be going off the board, so I'm going to redo that just right a little bit further to the right. 18 is 2 times 3 times 3. 24, if you did the factor tree, you get 2 times 2 times 2 times 3. Okay, so we know that 18ab squared could be written as 2 times 3 times 3 times a times b times b. So here's our 6 times 3 is 18, a, b to the second. Same as that. 18a, b to the second. 24 is 2 times 2 times 2 times 3. A squared is a times a and times b. Now I can start looking for factors that are in the numerator and in the denominator. Well, here's a 2 here and a 2 here. Plus them off. No more 2's up here, so I can't do anything here. I can divide by 3 and divide by 3 here. I can divide by a here and divide by a here. No more a's in the numerator, but they do share a b. And now I can do my multiplication. It would be 1 times 1 times 3 times 1 times b times 1. Which would be, well, these 1's aren't going to change the product. This is 3 times b. And all these 1's aren't going to change the product. So it's really 2 times 2 is 4 times a, which we write as 4a. So when you simplify this, it would be 3b over 4a. Another way you can do that is to say, I know the greatest common factor of 18 and 24 is a 6, so I can divide 6 into 18 3 times and 6 into 24 4 times. And let's put a 1 here. There's 1a in the numerator and 2 in the denominator, so I can take away one of the a's here and one of the a's here, leaving 1 left. I can take away this 1b. If I take away 1b from the bottom, from the denominator, I take away 1b from the numerator, leaving, there were 2, now there's 1. So it's 3b over 4a. Same thing. So that's a pretty quick overview of 4 or 5 multiplying by rational numbers. And we're going to need a fair amount of practice to become expert at that. So this is a kind of a challenging lesson, but hang in there, you can get it.